Most people think vitamin D is a bone supplement. Something elderly people take. Something your doctor mentions once and you forget about. They are wrong. Vitamin D is not a vitamin. It is a hormone, one of the most powerful signaling molecules in the entire human body. And right now, over 1 billion people on Earth are deficient in it without knowing. Their bones are weakening. Their immune systems are struggling. Their brains are misfiring. And they have no idea that one molecule is connected to all of it. Today we are going inside the human body in full cinematic 3D animation, and we are going to show you exactly what vitamin D does inside your cells, your organs, and your brain. What happens when you have enough? And what is silently breaking down inside you right now if you do not, and the part that will genuinely change how you think about this. Vitamin D does not just affect one system. It controls over 200 genes across nearly every organ in your body. We are going to show you exactly what that means. Stay with us, let's go inside. First, what vitamin D actually is. Because almost everything most people believe about it is incomplete, when ultraviolet B rays from sunlight hit your skin, they trigger a chemical reaction in the epidermis that converts a cholesterol compound into a precursor molecule called cholecalciferol, vitamin D3. This molecule then travels through your bloodstream to your liver, where it is converted into calcidiol. From the liver it moves to your kidneys, where it undergoes its final transformation into calcitriol, the biologically active form of vitamin D that your body actually uses. This is why vitamin D is classified as a hormone and not a vitamin. A vitamin is a nutrient your body cannot produce and must obtain from food. But your body manufactures vitamin D itself, from sunlight, and it acts on target cells through hormone receptors the same way testosterone and estrogen do. It was misclassified over a century ago and the name stuck. The vitamin D receptor, called the VDR, is found in virtually every cell in the human body. Your bones. Your brain. Your heart. Your immune cells. Your gut lining. Your lungs. Your pancreas. When active vitamin D binds to this receptor, it enters the cell nucleus and directly regulates gene expression. It turns genes on and off. Over 200 of them. This is why vitamin D deficiency does not cause one problem, it causes many, simultaneously, across multiple organ systems. If you did not know vitamin D was a hormone that controls over 200 genes, that is exactly why this channel exists. Make sure you are subscribed so you never miss what we show you next. Now let us go through what vitamin D is actually doing inside each major system of your body, starting with the one most people already know, your bones. Your bones are not static structures. They are living tissue constantly being broken down and rebuilt through a process called bone remodeling. Specialized cells called osteoclasts dissolve old bone while osteoblasts build new bone in its place. This cycle requires calcium, and calcium absorption from your gut requires vitamin D. Without sufficient vitamin D, your intestines cannot absorb dietary calcium efficiently, regardless of how much calcium you consume. Your body responds by releasing parathyroid hormone, which pulls calcium out of your bones to maintain blood calcium levels. Over months and years this silent withdrawal weakens your bone structure from the inside, a process most people do not notice until a fracture reveals the damage that has already been done. This is what rickets looks like in children, soft, deformed bones from years of vitamin D deficiency during development. And in adults the equivalent is called osteomalacia, softening of the bones, which is frequently misdiagnosed as fibromyalgia or chronic fatigue because the primary symptom is deep bone pain that most doctors do not immediately connect to vitamin D. Now your immune system, and this is where the science becomes extraordinary. Every immune cell in your body, T cells, B cells, natural killer cells, macrophages, carries the vitamin D receptor. When vitamin D binds to these receptors it does two things simultaneously that seem contradictory but are both essential. It enhances your innate immune response, the fast-acting first line of defense that responds immediately to infection. Vitamin D directly stimulates the production of antimicrobial peptides called defensins and cathelicidins, natural antibiotics your body manufactures itself that punch holes in bacterial and viral membranes. Without adequate vitamin D, this first-line production is measurably reduced. At the same time, vitamin D modulates your adaptive immune response, preventing it from overreacting. It suppresses the inflammatory cytokines responsible for the immune system attacking the body's own tissue. This is why low vitamin D levels are consistently associated with autoimmune diseases, multiple sclerosis, rheumatoid arthritis, lupus, type 1 diabetes, and inflammatory bowel disease. In every one of these conditions, the immune system has lost its regulation, and vitamin D is one of the molecules responsible for maintaining that regulation. The same mechanism explains the seasonal pattern of respiratory infections. In winter, reduced sunlight means reduced vitamin D production, which means reduced antimicrobial peptide production, which means bacteria and viruses find a less defended host. This is a significant part of why flu season exists. This is exactly the kind of science this channel was built to show you. If nobody has sent you here before, hit subscribe. We go inside a new system every week. Your brain contains vitamin D receptors throughout, in the hippocampus, the cerebellum, the cortex, and the brainstem. And the research connecting vitamin D deficiency to brain function is among the most compelling in modern neuroscience. Vitamin D regulates the synthesis of neurotrophins, growth factors that support neuron survival, growth, and connectivity. The most important of these is brain-derived neurotrophic factor, BDNF, which is essential for learning, memory formation, and emotional regulation. Low vitamin D levels consistently correspond to low BDNF levels, and low BDNF is one of the most reproducible biological findings in clinical depression. Multiple large-scale studies have found that people with the lowest vitamin D levels have significantly higher rates of depression, anxiety, and cognitive decline. Vitamin D deficiency has been identified as a risk factor for Alzheimer's disease, with the proposed mechanism being vitamin D's role in clearing amyloid beta plaques from brain tissue. The same plaques we showed you in our sleep video are linked to Alzheimer's progression. This does not mean vitamin D supplementation cures depression. The relationship is complex and multidirectional. But what the evidence clearly shows is that a brain operating without adequate vitamin D is a brain operating below its biological capacity, in ways that affect mood, memory, and cognitive function simultaneously. Your heart and cardiovascular system are also major targets of vitamin D signaling. The VDR is expressed in cardiac muscle cells and in the smooth muscle cells lining your blood vessels. Vitamin D regulates the renin-angiotensin system, the hormonal pathway controlling blood pressure. Without adequate vitamin D, renin production increases, driving up blood pressure and placing greater mechanical stress on the heart and arterial walls. Epidemiological data consistently shows that populations with lower vitamin D levels have higher rates of hypertension, heart failure, and cardiovascular mortality. People who live at higher latitudes, further from the equator with less sunlight, have measurably higher cardiovascular disease rates than populations closer to the equator. While multiple factors contribute to this pattern, vitamin D's role in cardiovascular regulation is now well established in the scientific literature. Your pancreas produces insulin in response to rising blood glucose. The beta cells of the pancreas that manufacture insulin carry vitamin D receptors, and vitamin D directly supports beta cell function and survival. Deficiency impairs insulin secretion and reduces insulin sensitivity in peripheral tissues. This is why vitamin D deficiency is a significant and independent risk factor for type 2 diabetes, and why improving vitamin D status in deficient individuals measurably improves glucose metabolism. Now, who is deficient and why? Over 1 billion people globally have insufficient vitamin D levels. This is not a fringe statistic. It is one of the most prevalent nutritional deficiencies on Earth. And the reasons are structural, built into how modern life is organized. Your skin requires direct UVB sunlight to produce vitamin D, not light through glass, not overcast sky light, not indoor lighting. The angle of the sun matters. In winter at latitudes above 35 degrees north or south, the sun's angle is too low for UVB rays to reach the Earth's surface at all. In those regions, no amount of outdoor time during winter months will produce meaningful vitamin D. Melanin, the pigment that gives darker skin its color, absorbs UVB radiation and reduces vitamin D synthesis. People with darker skin tones require significantly more sun exposure to produce the same amount of vitamin D as people with lighter skin, making deficiency substantially more common in darker skin populations. Particularly those living at higher latitudes, sunscreen with SPF 30 blocks approximately 95% of UVB radiation, eliminating most vitamin D synthesis. Clothing coverage, indoor work, and screen-based lifestyles further reduce exposure. Age reduces synthesis efficiency. People over 65 produce approximately 4 times less vitamin D from the same sun exposure as younger adults. Dietary sources of vitamin D are limited. Oily fish, egg yolks, and fortified foods provide some but rarely sufficient amounts to maintain optimal levels without sunlight or supplementation. What does optimal actually mean? This is where significant scientific debate exists. The conventional medical definition of vitamin D deficiency is a blood level below 20 nanograms per milliliter. Many researchers in the field argue this threshold is too low, set based on bone health alone, ignoring the broader systemic effects of vitamin D. Some research suggests optimal function across immune, neurological, and cardiovascular systems requires levels between 40 and 60 nanograms per milliliter. The only way to know your level is a simple blood test, 25-hydroxyvitamin D, which your doctor can order or which you can access through direct testing services in many countries. Supplementation with vitamin D3, the same form your skin produces, is widely considered safe at doses up to 4,000 IU daily for most adults, with higher doses sometimes used therapeutically under medical supervision. Vitamin K2 is frequently recommended alongside vitamin D3 supplementation because it helps direct calcium to bones rather than soft tissues, an important consideration when vitamin D is improving calcium absorption. Step back and consider what vitamin D actually is. It is a hormone manufactured by your skin from sunlight. Activated by your liver and kidneys, carried to virtually every cell in your body, and used to regulate over 200 genes controlling bone metabolism, immune defense, brain function, cardiovascular health, blood sugar regulation, and inflammatory control, simultaneously. The reason deficiency causes so many seemingly unrelated symptoms, fatigue, bone pain, recurrent infections, low mood, muscle weakness, brain fog, is because it is not one system failing. It is a global reduction in biological function across every system that depends on this single molecule to operate at capacity. Your body was designed to get vitamin D from the sun. Modern life has made that harder than at any point in human history. The solution is not complicated. Get tested, understand your level, and make an informed decision about sun exposure and supplementation with your doctor. If this changed how you understand what is happening inside your own body, that is exactly what this channel is here for. We go inside the human body so you finally understand what it is doing for you and what it needs from you. Subscribe and turn on notifications. We go inside a new system every single week. And if you want to keep going right now, we have broken down what your liver is doing 24 hours a day, what happens inside your heart during a heart attack, and what your brain is doing while you sleep. Watch those next. We will see you inside.